Chapter 6 Application of Derivatives Exercise 6.3 or 6.5 in the last year textbook. Question number 3, that is, find the local maxima and local minima if any of the following functions. Find also local maximum and local minimum values as the case may be. First question, that is, f of x is equal to x square. So we will be having f of x that is equal to x square. Now we will be finding what is f dash of x, that is d by dx of x square, that is 2x. When f dash of x is equal to 0, 2x equal to 0, x is 0 then. Now what is f double dash of x, that is d by dx of 2x, that is 2. So we know that 2 is greater than 0. Since 2 is greater than 0, it is a positive quantity and we can say we have a local minima here. So the local minimum value we have is f of x equal to x square. We are applying instead of x, that is 0, that is f of 0, that is instead of x square, that is 0 square. So f of 0 is 0 itself. So at x equal to 0 we have the local minimum value and we don't have the local maxima here. Next question, that is the second question, that is g of x is equal to x cube minus 3x. So what is d dash of x, that is d by dx of x cube minus 3x, that is d by dx of x cube 3x square, d by dx of minus 3x, that is minus 3, or g dash of x is equal to 3x square minus 3. What is g dash of x when it becomes 0? That is 3x square minus 3 equal to 0. Taken 3 outside, that is 3 into x square minus 1 equal to 0. So we have the value x square minus 1 equal to 0, or x have the value plus 1 or minus 1. Now what is d double dash of x, that is d by dx of 3x square minus 3, that is 3 into 2x, that is 6x. So g double dash of x is 6x. So we have got g double dash of x. Now at x equal to plus 1 and x equal to minus 1. So at x equal to plus 1, what is g double dash of x, that is g double dash of 1, that is 6 into 1, that is 6, which is greater than 0. That means we are having a local minima here. So what is the local minimum value, that is we are applying instead of g of x, g of 1, that is g of 1 is equal to 1 cube minus 3, or that is minus 2. So local minimum value is at minus 2. Now what is g double dash of x at x equal to minus 1, that is g double dash of minus 1, that is 6 into minus 1, that is minus 6, which is less than 0. So we can have a local maxima here. What is g of minus 1? That is minus 1 whole cube minus 3 into minus 1, that is minus 1 plus 3, that is 2. So the local maximum value is 2. So we have got local maximum value and local minimum value. Now moving to the next question, that is the third question, that is h of x is equal to sin x plus cos x where 0 less than x less than pi by 2. So we have the question h of x is equal to sin x plus cos x where 0 less than x less than pi by 2. What is h dash of x, that is d by dx of sin x plus cos x. d by dx of sin x, that is cos x, d by dx of plus cos x, that is minus sin x. So we have cos x minus sin x. When h dash of x is equal to 0, we have cos x minus x is equal to 0, where cos x is equal to sin x. So at the time when cos x is equal to sin x, in between 0 to less pi by 2, the ranges of x should be from 0 to pi by 2. We have the value of x, that is pi by 4 at that time. Now we will be finding what is h double dash of x, that is d by dx of cos x minus sin x, d by dx of cos x, that is minus sin x, d by dx of minus sin x, that is minus cos x. So we have minuses taken outside, so sin x plus cos x, that is h double dash of x. So when h double dash of x at x equal to pi by 4, that is h double dash of pi by 4, that is minus of sin pi by 4 plus cos pi by 4, that is minus of sin pi by 4 1 by root 2, cos pi by 4 again 1 by root 2. So we have minus 2 by root 2, cancelling both numerator and denominator. We have h double dash of pi by 4, that is minus root 2, which is less than 0. So since minus root 2 is a negative quantity, we have the local maxima here. So what is the local maximum value? So h of pi by 4, that is h of pi by 4 is sin x plus cos x we are applying in that equation, the first equation, that is sine of pi by 4 plus cos of pi by 4, that is 1 by root 2 plus 1 by root 2, that is 2 by root 2, or we have the remaining, that is root 2. So at root 2 we have the local maximum value. So we have got the local maximum value at root 2 and there is no local minima value for this question. Now fourth question, that is f of x is equal to sin x minus cos x, where 0 less than x less than 2 pi. So we have f dash of x, that is d by dx of sin x minus cos x, d by dx of sin x, that is cos x, d by dx of minus cos x, that is plus sin x. So we have f dash of x is equal to cos x plus sin x. Now when f dash of x is equal to 0, that is cos x plus sin x is equal to 0. So at that time cos x is equal to minus sin x. So in between the value 0 less than x less than 2 pi, we have two values for x that satisfy the condition cos x is equal to minus sin x. That is, x can be neither 3 pi by 4 or 7 pi by 4. So we have two values in between 0 to 2 pi for x. So we have f double dash of x, that is d by dx of cos x plus sin x, that is minus sin x plus cos x. Now when f double dash of x at x equal to 3 pi by 4, that is f double dash of x is equal to minus sin 3 pi by 4 plus cos 3 by 4 at x equal to 3 pi by 4, that is minus 1 by root 2 minus 1 by root 2. So we have minus 2 by root 2, that is minus root 2. Minus root 2 is less than 0. So we have the local maximum value here. What is the local maximum value? That is f of x. We are applying it in the equation sin x minus cos x. So f of 3 pi by 4 is equal to sin 3 pi by 4 minus cos 3 pi by 4. That is 1 by sin 3 pi by 4. That is 1 by root 2 cos 3 by 4. Again 1 by root 2. So we have the value, that is root 2. That is the local maximum value. Now at x equal to 7 pi by 4, we have f double dash of x, that is minus sin x plus cos x, right? Minus sin of 7 pi by 4 plus cos 7 pi by 4. That is minus of 1 by root 2 plus 1 by root 2. So we have the answer root 2, which is greater than 0. So we will be having a local minima here. So what is the local minimum value here? That is f of 7 pi by 4, which is equal to sine of 7 pi by 4 plus cos of 7 pi by 4. So when we solve, we have the answer minus root 2. So the local minimum value is minus root 2.